Welcome to my exciting summary of conversations with AI on the colonization of Mars, the fourth planet from the Sun and the second closest to Earth. Mars, also known as the Red Planet, has long fascinated humans with its potential for sustaining life. In recent years, the idea of colonizing Mars has gained traction as a potential solution for humanity's growing population and dwindling resources on Earth. We will explore the resources available on Mars, the conditions on the planet, and why humans would benefit from colonizing it. We will also delve into the potential problems this could cause, how we would reach Mars, what we would need to do after we reach the planet, and the technology required to make it happen. Humans would benefit from the colonization of Mars in several ways. First and foremost, considering our track record of epic mistakes as a species, it's not a bad plan. It seems much of our best work first requires countless failures before true success. Mars has a wealth of resources that could be used to sustain human life and support industry. First, let's take a look at the resources that can be found on Mars. The planet has a thin atmosphere, but it does contain carbon dioxide, which can be used for growing plants and making oxygen. Mars also has water in the form of ice, which can be used for drinking and growing crops. The planet has a variety of minerals, including iron, aluminum, and silicon, which can be used for building structures and manufacturing materials. Once we reach Mars, we would need to establish a base on the planet. This would involve building structures to protect against the harsh conditions and creating a self-sustaining environment, creating a source of food, oxygen, and water with a whole new meaning to use in the outhouse. We would also need to establish communication with Earth and set up a means of transportation on the planet's surface. Currently, we have technologies such as 3D printing, which can be used to create structures on Mars, instead of bootleg 40K models. NASA's Mars 2020 mission has successfully landed the Perseverance rover on the planet, which is currently collecting samples of the Martian soil. However, there is still a lot of technology that needs to be developed in order to successfully colonize Mars. One major area of focus is on the field of propulsion systems, as we currently do not have a means of getting humans to Mars in a reasonable amount of time. New materials need to be developed that could withstand the harsh conditions on Mars. Finally, we need to develop a sustainable means of producing food and oxygen on the planet. Growing plants and making oxygen on Mars would be a critical component of establishing a sustainable colony on the planet. The thin atmosphere of Mars is not breathable for humans, so creating an environment where plants can grow and produce oxygen would be essential for human survival. One approach that has been proposed is using a greenhouse to grow plants. This would involve creating a sealed environment where temperature, humidity, and light can be controlled. The greenhouse would also need to have a system for recycling water and nutrients for the plants. Additionally, it will have to have a way to filter and recycle the air inside to make sure the colony's inhabitants can breathe. Carbon dioxide, which makes up about 96% of Mars' atmosphere, can be used as a source of carbon for plants. The process of photosynthesis would convert carbon dioxide into oxygen, which could then be used by humans. Another method that has been proposed is using a process called terraforming to change the atmosphere of Mars. Terraforming would involve releasing gases such as oxygen and water vapor into the Martian atmosphere to create a more Earth-like environment. This process would take a significant amount of time and resources, but it could potentially make the planet more hospitable for human life in the long term. Currently, NASA's Perseverance rover has successfully collected samples of Martian soil and demonstrated that it contains enough water, ice, and nutrients that it could be used to grow crops. The rover also has a device called the MOXIE experiment, which will convert the carbon dioxide in the Martian atmosphere into oxygen, which is pretty amazing. Growing plants and making oxygen on Mars would be a critical component of establishing a sustainable colony on the planet. With recent discoveries and ongoing missions on Mars, we are getting closer to the solutions of these challenges. The conditions on Mars are harsh, with a temperature ranging from -80 degrees Celsius or -112 degrees Fahrenheit at the poles to 20 degrees Celsius or 68 degrees Fahrenheit at the equator. And you thought our winters got cold. The planet's thin atmosphere and lack of a protective magnetic field means that the surface of Mars is bombarded with harmful radiation from the sun. This can cause damage to DNA and increase the risk of cancer for humans living on the planet. However, recent research has shown that the planet's soil can be used to create a protective layer against radiation. In terms of materials, the harsh conditions on Mars would require new materials that can withstand extreme temperatures and radiation. The buildings and habitats on Mars would need to be able to withstand extreme temperature fluctuations and the high levels of UV radiation. The materials used for constructing the habitats and other structures would need to be able to withstand the high levels of dust and volatile conditions on Mars. Using the planet's soil to create a protective layer against radiation is an area of research that has been proposed as a way to make the Martian surface more habitable for humans. One proposed solution is to use the Martian soil, or regolith, to create a barrier against radiation. Regolith, a term used to describe the inorganic blanket over unfragmented rock. The regolith on Mars is rich in iron and other elements that can absorb and scatter radiation. The idea is to use the regolith to create a layer that would shield the surface from radiation. This could be done by constructing walls, roofs, and other structures using the Martian soil. By crushing the regolith and mixing it with a binder, such as cement, to create a material that can be used to construct walls and other structures. Researchers have studied using a special kind of concrete called lunacrete, which could be the coolest name for concrete I've ever heard. It can be made using the Martian soil by using a binding agent. This type of concrete is extremely durable and radiation resistant, making it an ideal material for constructing radiation shields on Mars. Recent research has also focused on developing specialized coatings that can be applied to the surface of habitats and other structures that can help to protect against radiation. Some of these coatings use materials such as boron carbide, which is known for its excellent radiation shielding properties. In summary, using the planet's soil to create a protective layer against radiation is an area of research that has been proposed as a way to make the Martian surface more habitable for humans. The proposed solutions using the regolith to create a layer that would shield the surface from the radiation by constructing walls, roofs, and other structures using the Martian soil, or by creating a layer of shielding material by crushing the regolith and mixing it with a binder, or by specialized coatings that can be applied to the surface of habitats and other structures that can help to protect against radiation, are fascinating areas of research. Much more research needs to be done to validate the feasibility and effectiveness of these solutions, though. The colonization of Mars could lead to significant advancements in technology, particularly in the fields of propulsion systems and materials. Currently, the most viable option is using rockets, with NASA and SpaceX being two of the leading organizations in this field. The journey to Mars would take several months and would require a spacecraft capable of sustaining human life during the trip. In terms of propulsion systems, the current technology used to launch spacecraft into space is not efficient enough to get humans to Mars in a reasonable amount of time. The trip to Mars would take several months, and the spacecraft would need to be able to sustain human life during the journey. Developing new propulsion systems that can achieve this would be a major area of focus. Some of the proposed solutions include the use of nuclear propulsion, solar sails, and antimatter propulsion. Nuclear propulsion would use nuclear power to heat the propellant and create thrust. Solar sails would use the energy from the sun to propel a spacecraft. Antimatter propulsion would use the energy released by the collision of antimatter particles with matter. However, these technologies are still in early stages of development, and more research needs to be done. Now, this is a great spot to pause a minute and go over some of the limitations of artificial intelligence. For all the speed and efficiency it demonstrates, AI is only as smart as its data set at the time and is not connected right into the internet to understand the newest and emerging technologies. A great example of this was with my discussion about this topic with the AI. It was completely oblivious to the fact that NASA has just released new information in regard to its nuclear fusion drives for spacecraft. For example, NASA selected a new concept for Phase 1 development into a new form of nuclear propulsion, using a combination of nuclear thermal propulsion and nuclear electric propulsion, also known as NTP and NEP. This is part of their NIAC program for 2023. This new bimodal NTP and NEP with a wave rotor topping cycle is just one of 14 selected for Phase 1 development. The fascinating part of this combination of the two systems, with current estimations, could potentially lower travel time to the Red Planet to as little as 45 days. This is a significant improvement over current technology. Now, I could go on with significant detail about these emerging technologies involving nuclear propulsion, but that is not what we are here for, and simply wanted to incorporate these details to help point out the limitations of AI at this time, and the fact that I find this new technology to be an important and amazing advancement in our goal of reaching Mars, with hopes of one day colonizing the planet. Another important area of technology that would need to be developed is the technology for extracting and processing resources on Mars. This would include developing new technologies for extracting water, extracting minerals, and processing materials. Establishing communication with Earth from Mars would be a critical component of a successful colonization mission. The approaches that have been proposed include using a network of satellites orbiting Mars to relay communications between the planet and Earth, using a deep space network, or DSN, on Earth, and using laser communication systems. These communication systems need to be reliable, robust, and able to withstand the harsh conditions of space and the radiation environments of Mars. The distance between Earth and Mars can vary depending on their position in their respective orbits, but it can be as far as 400 million kilometers, which is about 250 million miles. Therefore, it would require a reliable and complex communication system to transmit information, data, and communication between Earth and Mars. Using a network of satellites orbiting Mars to relay communications between the planet and Earth, these satellites would need to be equipped with powerful transmitters and receivers to transmit data, voice, and video communications over vast distances. Additionally, the satellites would need to have the ability to withstand the harsh conditions of space and highly radioactive environment of Mars. Really getting a theme about the radioactivity of Mars here. Another approach is the use of deep space networks, DSNs for short, which is a system of large radio antennas on Earth, and they are used to communicate with spacecrafts and landers on other planets. This system uses large radio dishes, such as the one at NASA's Deep Space Network, which are capable of communicating with spacecrafts at great distances. These dishes use high-frequency radio waves to transmit and receive information, and they would be capable of communicating with a lander or orbiter on Mars. Additionally, some researchers propose the use of laser communication systems, which would use a beam of light to transmit information between Earth and Mars. This method would be faster than traditional radio communication, and would allow for a higher data transfer rates. The research and development of these technologies would not only benefit the colonization of Mars, but also other space explorations and terrestrial applications. Colonization of Mars is a complex and ambitious endeavor that would require significant advancements from where we currently stand, but it is nonetheless an intriguing endeavor and may be humanity's only hope of long-term survival, and it is a stepping stone for humans to take their place among the stars. Thanks for watching. Subscribe for more intriguing results of my conversations with artificial intelligence.